Okay, this is part 2 of November 11th's notes on star formation. So you're watching this because you already finished the characteristics of a star, and now we need to talk about how stars form. Okay, so if I'm looking at this, how long a star lives depends on its mass. So if we're looking here, I asked one of my blocks, which one do you think would live longer, an average star or a massive star? And one person said, well, an average star, actually, they said, the first student said, well, a massive star would probably live longer because there's more mass, there's more fuel to go through. And then another student was like, I don't know if this would live the longest because look, it's blue. We just learned that blue is the hottest color. There's more energy, so it's probably burning through its fuel more quickly, and that is right. So a massive star is going to have a shorter life. It'll go through these stages faster than an average star. So let's start looking at what are some of the steps. And you'll notice no matter which star, if it's an average size star or a massive size star, they all start as stellar nebula. Okay, so here we go. A star, it depends on its mass. The more massive, the shorter the life. Let's highlight that. A stellar nebula is a cloud of gas and dust where gravitational attraction causes the cloud to begin to collapse. So this is one beautiful image of a nebula. You also saw in that one video that we did, the Eagle Nebula. That was one of our first images of a nebula that made us say, oh, that's where stars start. So it's a cloud of gas and dust. That's what a stellar nebula is. And it's going to start collapsing in on itself, okay? The next stage is the protostar stage, okay? The nebula is going to crunch down. Gravity is going to pull in on this cloud of gas and dust, and it's going to start heating up. So the nebula heats up and increases its density and pressure. As it heats up, just like anything that gets hot, eventually it's going to start to glow. Now, just because it's glowing, that doesn't mean it's a star. When it's a protostar, just like a prototype of something, a prototype is what you base everything else off of. It's like the first thing that they can try and see, like, oh, does this like a prototype of a car. It's before it becomes like really manufactured. Or for our instances, a protostar is like right before it becomes a real star. So it's not a real star in this stage, even though it has star in there. Proto, it's like the pre-stage before it becomes a real star. So it's glowing. It's a glowing ball of mass. So the nebula heats up. That's kind of the most important part there. All right, and then a star will be born when extreme temperatures causes the pressure and gravity to be great enough to start a fusion reaction. So the main thing you need to highlight and star and be aware of, a star is born when, highlight that, fusion starts. Fusion is the big kicker there. So you'll have this protostar stage where it's warm, it's starting to glow, and then bam, once fusion begins in its core, then it becomes a real star. So fusion is when you're bringing two atoms together, you're fusing them together, and for stars, it all starts with hydrogen, okay? So atoms of hydrogen join to form atoms of helium. All right, nuclear fusion occurs in the sun's core, right there, and I think you guys have an image of, all right, here's this star. There's hydrogen coming together, it's making helium. Okay, so atoms of hydrogen join to form atoms of helium. If it helps you to remember that fusion means you're fusing together and bringing together two things, you can write fusion, fusing together. I don't know. Do what you got to do to remember. And then hydrogen atoms combine to form helium and releases huge amount of heat, radiation, and energy. So in here, where fusion is happening, you have heat, radiation, and energy popping out of there every time you bring atoms together. And it takes over 10,000 years for the light to get from the sun's core to the sun's surface. Okay? So it occurs in the core. Hydrogen atoms combine to form helium, and they release a huge amount of heat, radiation, and light. And it takes a while for it to get from the core out to the surface. Okay, so it is a balance though. So it's kind of like a balloon. You have forces that need to be balanced. For a balloon, you have gravity pushing in, but you have that air pressure, the air you put into it, pushing back out. Same idea with a cloud, a star. I know what I'm talking about. Gravity is pushing in, and there needs to be a force pushing outward, or it'll implode. So you have the core fusing, pushing out energy. Okay. The more massive a star is, the more gravity pushing down. And that's one of the reasons why stars that are huge die out so quickly, because there's more gravity pushing down. The star has to do more work to push against that. And so it uses up its fuel faster. Okay. Let me make sure I didn't miss anything. Here we go. So a star's life is a balance of forces. Gravity pulls in. The force of attraction that pulls the star's matter increases its density. And then nuclear fusion pushes out. Heat caused by fusion creates internal pressure. So I'm going to highlight pulls in. Gravity pushes in on it. Nuclear fusion pushes out. So there's these two opposite reactions happening. Okay. Now, when hydrogen is happening or fusing, that's called the main sequence stage. And that is like, it's kind of like the prime of that star's life. You are in the prime of your life right now, hopefully, where your health is pretty good, and you will experience that up until you're like 50 or 60, all right? Where hopefully your body is doing what it's supposed to. That stage, that prime of the star's life, is called the main sequence stage. 90% of the star's life cycle is here, just like, I don't know, when you get into the prime of your life, maybe middle school? Let's say once you hit puberty, so like late middle school until you're like 60 or something. Okay, so a lot of your life is in the prime of your life, and it's the same with a star. The main sequence stage, 90% of the star's life cycle, it's actively undergoing nuclear fusion of the element hydrogen, and that's the key there. And I want you to highlight that in the main sequence stage, you have hydrogen fusing. That is a big deal, because once it runs out of hydrogen, everything goes downhill. It starts to die. And our sun is in its main sequence stage. I also want you to highlight that it's 90% of a star's life cycle. So that's where these notes are going to end today on this page. Okay. And tomorrow we'll go into what happens once it runs out of hydrogen. What happens to that star? Yeah. So hopefully this was informative and helpful, and you now know how a star starts its life. Bye.